Hi, in this video, let's discuss how to solve such an equation. 15 over 7y equals 4/3. So we right away notice we have fractions in the equation and we want to handle those fractions efficiently. Don't even think about converting those fractions into decimals or mixed numbers. That is not an efficient way to handle fractions. So this is how we're going to proceed. Firstly, a quick reminder. Solving an equation means finding all numbers y such that the equation is true. So we start out with assume there's a number y that does satisfy the equation. So by that assumption, then this guy is a number and so is this guy. And they're equal. That means on the number line, you can think of 15 over 7y and 4/3 being the same point. So now we can do all the operations we can do with numbers. So I rewrite the equation here. So this is a number and this is a number. I choose to multiply both numbers or both sides of the equation, if you want to say it that way, by the same number. I make a good choice as follows, and I'll explain to you why I make this choice. 15 over 7y. Remember, solving for y, I'm trying to isolate y or trying to get y by itself. So I noticed from another video, 15 over 7 multiplied by reciprocal is 1. So if I made that choice, so 15 over 7's reciprocal is 7 over 15. So I made that choice and multiplied both sides by 7 over 15. Thinking ahead that the 7 over 15 times 15 over 7 would be 1, and so this expression would be y. That is why I made the choice of multiplying both sides by 7 over 15 and not by any other number. So once I do that, then I get y here. Here I get 7 over 15 times 4 over 3. So that's just multiplication of fractions. I carry out and I get 28 over 45. So now we get y equals 28 over 45 is the solution once I have really checked and made sure 28 over 45 does satisfy the equation. Since I don't have any space here, I have the check workout here. I proceed as follows. I write the left hand side, which is 15 over 7y. I use an equality sign, and in the next step, I put in for y what I think is a solution, 28 over 45. Notice I do not multiply 15 times 28 out or 7 times 45. If you do that, you'll end up getting very big numbers and you'll have to carry out a division. Instead, I think ahead and I think, well, 15 and 45, there are some common factors. 5 does go into both of them and 7 goes into 7 and 28. So thinking ahead, I think instead of multiplying actually 15 and 28, I'm going to factor them out so I can apply the cancellation law of fractions. 15, I write it as 5 times 3. 28, I write it as 7 times 4. Here's my 7. 45, I write it as 5 times 3 times 3. Now you can see lots of common factors cancel out. 7 cancels out with this 7. This 5 and 3 cancels out with this 5 and 3. All I'm left with is 4 over 3, and there's my 4 over 3. So if you develop these efficient ways of calculations, then it will cut down on your amount of time and effort in solving such equations. So the way I proceeded was, here I noticed a fraction multiplied by the variable equals another fraction. An efficient way is simply to multiply both sides by the reciprocal of this. That would right away get y by itself. So that's one way of approaching. You could also proceed by the technique of clearing the fractions, in which case this 3 and this 7, if we didn't have them, we are thinking that would have made a good equation. So you can try that out. Multiply both sides of the equation by 21. The 7 times 3, the product of these two denominators. If you do that and proceed, you'll also arrive at the same solution. I recommend that you try that method out also. This is my preference because it's shorter, but if you choose to multiply both sides by 21 to clear the fraction and proceed in that manner, that would also be a correct way to solve this equation. But whatever you do, the message here is do not convert them into finite decimals. Well, you cannot convert these guys into finite decimals with the 7 and 3 in the denominator. Do not convert them into mixed numbers either. That is not an efficient way to handle this situation. So keep this in mind. Thank you.